Next, we have Mr. Deepu Chandran, Senior Technical Manager, LDRA India, presenting Secure Components in IACS and the Readiness with IEC 62443.
Hello everyone and welcome to my session on secure components in IACS and the readiness with IEC 62443 part 41. So in this 30 minutes, we are going to learn about the process control and need of functional safety. And then we are going to talk about IEC 61508, which is basically a standard for functional safety of programmable electronic and electrical devices. And with respect to the connectivity that we are introducing in today's world, it is more relevant to talk about IEC 62443 part 41, which is especially on component or device manufacturing life cycle. And also in deep, we will be discussing about the 8 practices which is described in IEC 62443 part 1. We will be looking at the technical process activities. I will be providing you an overview, and also we will look at how do we automate this process activity, because we have specification, we have the design information, we have verification and validation. So all these activities, how do we use an integrated and automated tool so that we can automate this life cycle activity and create the evidences that are necessary for certifying or qualifying the product according to the process guidelines. And we will summarize it with the benefits that we can leverage by using such kind of an automated process. So all of us know that we are talking about the connected world today, because we know that from where the industrial revolution happened, it had started with the mechanization, and we were using water power, steam power, and all those good old stories. We are all aware about it. And the second generation of industrial revolution happened with the mass production, with electricity and assembly lines were created. And in the third generation, we know that we have introduced computers into this activity and a lot of things were automated. And today we are talking about from automated activity to autonomous activities with connectivity. That means how all these systems can become independent of each other, and how the systems can collect the data from these activities, and how this data can be used to do an analysis which will help the complete process activity to make it in a better way, to improve the performance, to improve the efficiency. So all these things we can do it with CyberPhysical Systems, which are nothing but connected systems. So we are talking about such kind of systems today. Before getting into the details of such kind of system and its development, it is good to know about the cyber-physical systems, which is the core part of all these activities. The cyber-physical system consists of a physical layer where we can have sensors or actuators or microcontrollers or tracking devices. So usually it may be a piece of hardware, or it may be a firmware along with a piece of software which is actually collecting the device and doing some endpoint processing and sending the data back to the network layer. The network layer, we may be using communication protocols, and which may be included with the protocols like UART or CAN or 3G or 4G or ZigBee. So a lot of protocols are available today, and depending on the application what we are working on, we may choose the appropriate network. And the data collected from these endpoint devices or from the sensors are being transferred to a data storage. So huge file data storage will be used, such as Hadoop as an example. So either in the local server or in the cloud. So now the next activity is this data need to be analyzed appropriately using algorithms. So we may be using data filtering, data mining, and we may process the data that is required for us. And then we may be representing with simulation models to find out the optimal solution. And once the optimal solution is identified, definitely the feedback is going to be given back through the same set of layers to the final physical layer for an action, so that the microcontroller or sensors can again do the respective action for doing the job in a smart way. So the application layer may be with any kind of applications, like we are talking about smart factories, smart transportation, smart health, or smart building. So for any of these applications, the basic thing behind it is having this kind of layers where it can collect the data, analyze it, and make sure that the feedback is given back to the system, so that the system can work in a smarter and better way. So now we are getting into the details of IEC 62443, the security for industrial automation and control systems. So let me give you an overview of the IEC 62443 standard. So it consists of four major parts. The first one is talking about the general things like the terminologies, the glossary, and the system security compliance metrics, as well as the ISCS security lifecycle. And the second part is talking about the policies and procedures. And the third one is talking about the system and the system integration details. And the fourth one is talking about the product development requirements for components and devices, as well as the technical security requirements for IACS components. So we will be focusing much on the part 4.1 for component development. So now let us see the stakeholders in the process industry. So usually all these components are developed by the product supplier, and the product supplier need to follow IEC 6244341, the life cycle activities for secure product development. And in case if it is a safety related product, definitely the process activities related to IEC 61508 need to be followed. And then you develop the component, and you may be integrating the component as a subsystem or a system. It may consist of applications or sometimes embedded devices, or even the network components may be there, or even the host devices. So once the product is available, which is independent of the intended environment, we can supply the product to the system integrator, and the system integrator can configure the product for an instant of a industrial automation and control system. So basically, we may need to apply the part 3 for integrating the system as an automated solution, which consists of one system or n number of systems. So the system integrator will be following the aspects, the integration aspects related to the part 2 as well as the part 3. And the asset owner, which is nothing but basically the organization who owns these assets, they need to ensure that the policies and procedures are in place, and the operation and maintenance need to happen according to part 2 of IEC 62443. So this is the overview of the complete process according to IEC 62443. And now we need to talk about, once we develop the components, how do we ensure that safety and security is being built into the components or into the product that we are intending to supply for integrating into the IACS. So system safety, as we know that we are talking about avoidance of unreasonable risk, right? So that we can ensure that there is no harm to life or property or environment whenever there is a malfunction happens during the operation of a product. So we can either prevent it or we can control it. And similarly, when the system is connected to external world, we need to ensure that no vulnerabilities shall lead to losses. Traditionally, when we talk about web application, the losses may be related to financial, operational, or privacy. But right now, when we are doing critical activities, the secure system, in case of a threat, the losses may be related to safety. That means even if there is a threat which can harm the system, it may have an impact on life of people, property, as well as environment. So it is closely related, and we need to ensure that the development activity are happening as per the process guidelines, which is tailored for the product development. So all safety critical systems are cyber security critical if it is connected, but not all the cyber security critical systems are safety critical in nature. So now, once we understand this scenario, the product development has to start based on the tailored activities according to IEC 61508 as well as IEC 62443 part 4.1. So during the concept phase, we are supposed to define the scope of the product, and we are supposed to do a risk analysis. With respect to safety, as we are aware that we need to perform a hazard analysis and risk assessment to identify all the hazards, to classify all the hazards, and also to look at what is the priority of the classified hazards and how do we need to treat them. So similarly, in case of cybersecurity also, we need to ensure that a risk assessment has been done for all the threats. So the threats need to be identified, classified, and prioritized. So we may need to define safety goals for the functional safety, and security goals need to be defined for cybersecurity. So then we move to the requirement allocation. So the functional requirements, safety requirements, and security requirements need to be specified. Now, After that, we start with the product development activity. So product development activity will be according to the safety integrity level or according to the security levels which are defined as per the process. And we may need to specify the requirements for the system and the realization of the system, overall installation, commissioning, the safety or security validation, operations, maintenance, repair, and decommissioning has to happen according to the life cycle activities defined in this process. So it's basically a tailored process by putting in all the required activities from IEC 61508 as well as IEC 62443 will ensure that a safe and secure product is under development. So for safety, we will be looking at defense against random and systematic failures to protect from the harm. And for security, the motive is basically to defense against negligent and willful actions to prevent devices and facilities. So now let us look into the 8 practices which is defined by the part 4.1 of IEC 62443. So there is an overall umbrella of security management, because the security management is the responsibility of the organization, and the organization need to ensure that these management activities are being transferred to the product development also. So specification of safety requirements, security need to be inbuilt in the design, and during the implementation stage also we need to ensure that security has been built in, and verification and validation need to be done for the secure application, and the guidelines are also defined by the standard which need to be followed. So defense in depth is the key strategy or philosophy for secure product lifecycle development according to 62443. So now let us look into the lifecycle activities in detail. Specification of security requirements. So what is the driving factor for specifying the security requirements? So when I am developing a component or a product, I may need to ask few questions related to the product development. Do I need security capabilities in my product? So this question is like you can have trivial answers, and it may also lead to different other questions like am I connecting my device to external interfaces? So if your answer is yes, then definitely you need to specify the security requirements. And also you can ask questions like, am I exposing my device to the external world? So if the answer is yes, definitely then you may need to specify the requirements based on the risk assessment, what you are going to do. So once you are able to answer such kind of questions, so definitely that will give you information about what kind of a product you need to build. So definitely when it comes to security, you may need to specify the requirements for authentication, authorization, encryption, auditing, as well as physical security and protection of external interfaces. So now what need to be specified as part of the requirements? So we all know about functional requirements. So the requirements from the product security context need to be specified, and also the requirements related to the threat model, because the threats are already identified during the risk assessment stage, and we know that what threats are at higher priority. And also we may need to define the product security requirements. What are the boundary conditions? What are the interfaces available? And what data is going to be passed over the interfaces? So all these requirements, product related security requirements need to be specified. And also the content on the product security requirements need to be specified. And all these requirements need to be reviewed. So let us see an example of a security requirement. So you can see here, this is a product requirement for safety as well as security. So you can see the functional safety requirement. The control unit shall be monitored by a watchdog. That means in case of a failure, the watchdog will be able to monitor the signals, and it will be able to give us information about it. So when I'm writing down the security requirements seems like the control pins of the watchdog module shall not be exposed to external interface level. So if you're exposing these control pins, there is a chance that it can be used as a threat by someone. And also you can define the SIL levels or the security capability levels. So now once the requirements are specified, you may need to perform the verification for the requirements. The requirement verification involves 2 activities. One is reviews. So peer reviews or formal reviews can be done, and review notes can be recorded, and corrections can be taken up. And you can also do requirements coverage. Requirements coverage can be achieved through traceability. So here I'm just showing you a traceability from the system level requirements to high level requirements to low level requirement and even to the source code. So 100% forward and backward traceability, if you are able to establish, that gives you coverage for all your requirements, including functional requirements, safety requirement, as well as security requirements. So this is highly recommended by the functional safety as well as security standard. Now, moving forward from the requirements to the design, the objective is to develop a architectural design that realizes the security requirements, leveraging the analysis of what data types are being used, how the data will flow, how the software will be detecting the errors, and how the software will be able to recover from the errors. So that means we may need to identify the issues or fault uh, which is happening in the system, and we may need to even indicate about the fault, and we may try to prevent the fault. So that is what is the safety mechanism that or security mechanism that will be built into the product. So the aim is to ensure that there is data confidentiality, integrity, as well as availability in the design. So this will help us to enhance the dependability, trustworthiness, and resilience, because these are the properties of an ideal secure system. So we are trying to achieve it, even though we cannot achieve it 100%, but the level of assurance what we can provide can be always enhanced. So now coming to the implementation part, the process specified by this practice are used to ensure the product features are implemented securely. So you can see here, during the implementation also we can do reviews, and static code analysis may be able to detect coding errors related to division by zero or related to buffer overflows, buffer underflows, integer overflows. So there are a lot of issues which are already defined in the coding guidelines. So appropriate coding guidelines and rules can be applied, and you can detect all these violations at an early stage, and you can try to eliminate it. And also the identification of requirements, security requirements which are not implemented, so which can be identified during the reviews. And the examination of threats and trust boundaries and assets can also be done as part of the reviews. The application of secure coding standards will help you to ensure that potentially exploitable implementation construct are being avoided in the code or in the program. And also you can avoid banned functions, coding construct, or design patterns. Automated tools can be used to do this activity, so that all the team members will be doing the secure coding practices and the reviews for the code that is implemented. Validation of inputs can be done across the trust boundaries, and error handling mechanisms can also be verified. So once you do this, all this activity, it ensures that uh, the language related unspecified implementation defined or behaviors. So such kind of behaviors are not existing in the code that you have written. So here is an example for secure coding standards. So we have the MISRA standards, the CERT coding standards, and the common weakness enumeration or CWE coding guidelines. So the screenshot shows about selection of the coding guidelines for a project using the LDRA toolsuite, and easily we can customize the coding guidelines, apply it, and we can efficiently detect the vulnerabilities at an early stage. So the tools will help you to minimize the runtime issues during the development time itself. Now coming to the verification and validation activities defined by the process document IEC 6244341. So it asks you to test all the security requirements to ensure that all the requirements has been met for the product. And also it asks you to ensure that the security of the product is maintained when it is used in the product security context and configured to employ its defense in depth strategy. So not only the functional requirements, all the security requirements need to be verified. So test cases need to be created, and all the safety mechanism or security mechanism also you may need to create the test case, execute it, and verify it. And if there is a particular configuration that is being used during the installation, ensure that in the product security context, you are creating the test scenarios and you are executing it and verifying it. So security testing can be performed at various times by various personnel during the development life cycle based on the type of testing and the development model. So that is the recommendation by the standard, and also the standard provides you with the level of independence required for different security levels. Uh, so you may tailor the process guideline according to these requirements, and then you can perform the verification and validation activities. So now I'm getting into the details of the type of security requirements testing. Okay. So we can perform the functional testing of all the security requirements. Performance and scalability testing can be done. And also robustness testing, including boundary or edge condition, stress test, or malformed or unexpected input test, which are not specifically targeted at security, can be done. So usually in web-based application, we call this as fuzz testing, but in embedded application, it is robustness testing, where error guessing, error seeding, conditional boundaries, or even boundaries of the data types, you can provide it as an input. And the objective is to ensure that the functionality is not deviated when you provide it with a random combination of inputs. So that's what you try to do during the security requirements based test. So in a typical functional test, this is a screenshot which shows you that the functional inputs will be provided. You may be creating the test case, you may be executing it, and the functionality can be verified. And also we can visualize the functionality and see that how much percentage of code coverage has been achieved. So the possible path within the function or procedure is visible through the flow graphs, and you can identify which path has been executed and which path is not executed. So similarly, we can also perform security requirements test. The functional test may be able to cover maybe 100%, sometimes even less than that. So we can also make sure that a security requirements for a robustness test, we can apply it for the source code at the lower level. So you can see here, this is a selection of criteria for creating the robustness test inputs. So we can apply the min, mid, and max value. Min, mid, and max values right now I am preventing it in the loops. And I can also give cases like what are the abuse cases for a pointer. The use case may be pointing to a structure, accessing the structure element, modifying the structure element values, and you might have already tested that. But in case of the abuse cases, you may need to point to null. You may need to point to a dynamic or physical memory location, right? So there are a lot of cases we can do with a pointer. So similarly, with all these variables, how do you deal with all the abuse cases, and how do you create the automated test cases? So several number of automated test cases can be created based on the configuration I am using, and the tools will automate this process, and easily you can do a robustness testing. So here we can see the vulnerability testing techniques which are defined in the process guidelines. So you can see the abuse cases, malformed or unexpected input testing focused on uncovering security issues. So this is what we have seen in the previous slide about automated test case based on the random combination of input, where the abuse cases for the variables, as well as for the conditional statements, as well as for the boundaries, all this we can automatically test it. And also it recommends for attack surface analysis. So structural coverage is an example for embedded code, where once you get 100% coverage, that ensures that there is no possibility of attacks for a unintended piece of code lying in the application, because when we get 100% coverage, there is no unintended code available in the firmware. So that gives us more assurance related to attack surfaces on the code. And also black box level vulnerability scanning can be done, like a network based known vulnerability scan, so which is basically done for the web applications, which is equally applicable here as well. And finally, what I would like to say is that all this testing is based on the requirements. So you may need to map your functional requirements, safety requirements, as well as security requirements, and make sure that test cases are created and 100% structural coverage is achieved. So that will give you the confidence that the functional verification, the structural verification, safety related test cases, as well as security related test case has been executed, and you are confident about the implementation of safety and security mechanisms in the product. Now, what benefits you will be getting when you follow such kind of a process guideline. How the process is going to help you? So the process will ensure that the security capabilities are implemented correctly in the product, because you are getting a thumbs up from the process activities that, okay, the process recommendations are implemented in your product. And also any known vulnerabilities in the product are eliminated, because we have followed the process and we identified it and we eliminated it in the beginning itself, or during the process, or during the development activity itself. So now some questions which will come to our mind as a developer, or as a product manufacturer, like whether this kind of a process is enough to ensure, or to assure the security. What is the cost? Does it gives me a burden of additional cost? And how do I do it? Do I need additional manpower? Do I need additional tools? So we can answer all these questions in the next slide as a summary. So is it enough? Yes, it will be enough, because you have already identified the product and the usage and the context in which the product is manufactured and the intended usage. So the process activities are tailored according to the security capability levels, which are defined in the planning stage itself. So that will be enough for the level of assurance that you can provide. The justification for the claimed level of assurance is sufficient to inspire the confidence in the end user. And how much it costs? We can make use of the same tools and process which is followed for the functional safety product development. Only thing is, like, the rigor at which what you do, and the cases, how you will be testing it, and the method which will be applied for the testing. So these all differs. So the rigor and activities may differ, but the same tools and the same set of people will be able to do all this verification activity as well as development activity. So how is it achieved? Do I need additional manpower and tools? See, threat analysis and risk assessment requires a different level of expertise when we compare it with the hazard analysis and risk assessment. Because hazard analysis, if we have known experts for the product, and if we have a legacy of the product and maintenance related issue for maybe the past 3 years, 5 years, or 10 years, which is good enough to do a hazard analysis and risk assessment. But for threat analysis and risk assessment, since it is evolving, we need experts from different disciplinary need to be available along with the product experts. And then all these stakeholders may need to do the threat analysis and risk assessment to identify the threats and classify it and prioritize it. So this is only one of the additional activity you may need to do it. Otherwise, most of the process activities can be performed with the same skills and tools. So my recommendation is look at the standard, tailor it for your need, and make sure that the process activities are applied wisely by using a qualified or certified, automated and integrated tools. So that will ease your process for product development according to IEC 62443 Part 4.1. So thank you very much. If you need more information, you can visit our booth or you can contact us.